So thank you everybody for attending today. So my name is Sean Weiss, Systems Engineering Manager at Fortinet for Western Canada. For those of you who don't know me, I've been at Fortinet for about 11 years, which is seems like forever now. I was employee number 768, and I think we're somewhere around 8,000 people now. So it's been a long and interesting ride. Previous to Fortinet, I've had experience working for MRV, which was basically an MPLS optical startup company back in the old days, the good old days. I also used to work at HP and McAfee, so I've been around. All right, so today what we're really going to look at is we're going to talk a little bit about designing an effective security operations strategy with DevSecOps. So we'll talk really about integration, automation, and especially how it can be applied to InfoSec today. So we'll talk a little bit about some of the limitations that we're being faced with in today's IT security environment, how integration and automation especially can really sort of help us overcome some of those limitations. So here's the agenda. We'll do a little bit of a lesson back in time. We'll have some fun with that one maybe. We'll talk a little bit about the state of security today. We'll talk about what DevSecOps is and isn't. And then we'll kind of take a bit of a different path. We'll maybe take a left turn at that point. We'll talk a bit about a security strategy in a general sense and how we can apply DevSecOps to a security strategy. And then hopefully we'll have some time left over and we'll do a bit of Q&A towards the end. All right, so let's talk a little bit about automation. Oh, I don't think my slides are moving. Give me a sec here, guys. Just noticed that. All right, here we are. All right, so if anybody can pop their hand up in the chat. I don't have a prize today, but I promise I'll get you one. And so here's the question for the prize. And I'm gonna put it out there. Automation. I'm gonna attribute the earliest prediction of automation to this gentleman right here. So for the $1 million question, for the grand prize at Fortinet, can anybody tell me who this gentleman is? That's the question. I'm looking for the name of the guy in this photograph. And don't say David Mitchell. For those of you who know David Mitchell at Fortinet, he's also got a great beard, worthy of anyone's PowerPoint, but it is not Dave Mitchell. This is somebody much, much older than that. So can anybody guess who this guy is? I'll give you guys a couple more minutes. So first to answer this question gets the grand Fortinet prize. And what you can do is send me your email in the chat, and I'll be sure to follow up with you with the prize. All right, so I'll give you 5 more seconds. All right, this is Karl Marx, right? So at a time when the light bulb hadn't even yet been invented, Karl Marx is basically in the mid 1800s, again, before the light bulb was even invented, predicting things about robotics that would replace humans in the workplace. And so Karl Marx has a quote that's pretty interesting, and this comes out of something that wasn't translated until the 1970s from German, but he had written something that was very futuristic. And he had written something along the lines of, once adopted into the production process of capital, the means of labor passes through a different metamorphosis, whose culmination is the machine, or rather an automatic system of machinery. The workers themselves are cast merely as its conscious linkages. So really what Marx was trying to get at was really the earliest predictions of automation and the effect that would have on human labor. Karl Marx, if nothing else, I mean, we all know him as a socialist and the father of socialism, but really for me, when you study Karl Marx, he was really a futurist. He was really all about predicting how capital and labor were interacting with one another during the Industrial Revolution. And there's some similar overtones to today with DevOps, as we see automation kind of taking over, what used to be very manual IT processes. All right, now another stat that had just come out from the World Economic Forum. This is a prediction about the job landscape as it's going to look in 2025. And what the World Economic Forum put out with some numbers was this interesting stat. What they predicted by 2025 was there would be an 85 million job being displaced by machines. So what they're basically saying is 85 million jobs are likely to be at risk by 2025. Jobs such as data entry clerks, administrative people, accounting, bookkeeping, payrolling clerks, auditors, factory workers, assembly workers. And the one thing all of this has in common, these are very manual, very process, very repetitive, mundane, if I can use that word, type of jobs. We'll talk more about this on the flip side in a minute. So let's kind of go into cybersecurity, or the state of cybersecurity today. So a couple of stats I want to throw out there that are going to have some relevance here as we kind of go through automation and integration and DevOps. 197 days, this was done by the Ponemon Group last year. 197 days was the average time to discover a data breach. 69 days is the average time to contain that breach. And 81% of those breaches weren't even discovered by the victim. They were discovered either by law enforcement, other partners, research companies, somebody other than themselves. So there's just some pretty telling stats that shows a pretty sorry state of affairs when it comes to our ability to respond. Now, here's a famous quote from Gartner. So Gartner will claim breaches and attacks are inevitable. So Gartner's had this quote. You've probably heard it before, and they're probably right, not to sound defeatist, but everyone is going to be breached at some point. And what really separates the adults from the kids in this business isn't so much your ability to just stop that breach, because we're all likely to be breached, but it's how do you deal with that breach after the fact? How fast are you at responding to that breach and minimizing the impact of that breach? For me, that's really what separates the professionals from the wannabes in this business. A couple other stats to throw out there. They're going to have some relevance to our discussion. There is about a 3 million shortage or shortfall of trained cybersecurity professionals today in the workforce. Really what this is pointing to is the fact that we can't even hire all of the people that we need from a cybersecurity perspective, even if we wanted to. There's just a shortfall of trained people to do the job. Another interesting stat from IDC was the average customer will have over 30 different unique security products. Now, we as vendors, and of course I come from the vendor space, so I'm all about throwing more toys at you, but it really seems like, you know, every time there's a new threat vector out there, we want to throw some new shiny whiz-bang toy at you. And that's why we've gotten to the state of things where your average customer has got 30 different cybersecurity toys at any one given point in time. That's a lot of things to worry about, a lot of things to be trained on, a lot of things to try to integrate, or when shit hits the fan, trying to go through some sort of triage process between all of these different products and trying to figure out what console do I need to go into and how do I cross-reference the SIM console versus the endpoint console versus my firewall and so on and so forth. So there's a lot being thrown at security operations people today. The other stat that I want to talk about is these two right here. So a stat was done, this was done by ESG Research. What they found is that 80% of organizations that were polled were basically complaining that their digital innovation was being slowed down by cybersecurity. So essentially, the business was not able to move at the speed of business because security, IT security specifically, was too often in their way. The other stat in this research, 71% of organizations believe that their team lacked basic DevSecOps practices. So basically saying things like integration and automation were lacking in their organization. So we got a long way to go. And that's really what we're talking about here today, right? The use of automation and integration. It's obvious that we need to do something different. Technology has to catch up with where the business wants us to go and at the speed that the business wants to go. And just to do a better job of cybersecurity as a whole. And that's really where automation and DevOps are going to become even more and more important. Now, on the flip side of that stat that I showed you from the World Economic Forum, those 85 million jobs that are essentially being lost to automation has actually created 97 new million jobs that are going to be centered around people that can take advantage of a DevOps mentality. So things such as data scientists, machine learning specialists, data specialists, or big data specialists, I should say, and then process automation specialists. So those jobs that are being lost to automation, somebody in the back end has got to create that automation. And there's actually more of those jobs that are going to be created than the ones that we're actually losing. All right, so let's go through some DevOps definitions. So I think through some of those slides that I just showed, really the crux of the problem here, we've got too many vendors, or at least two. You can never have too many vendors, of course, because I come from the vendor space. But no, seriously, we've got too many products, too few people to manage too many products. We're getting overloaded with alerts. We've got processes that are too slow or too manual. And we just have too few people to manage and operate this whole thing. So this is why automation and integration is becoming so important. And that's really what DevOps is, if nothing else. It's all about automation and integration. It's about reducing repetitive tasks, right? It's the ability to program and automate the remedial things in your day-to-day activities, leaving you as an operator to do things that are maybe more strategic. So rather than manually poring over logs, trying to search for an IP address or a domain or a URL, and then going into the firewall and hand bombing it into the blacklist, wouldn't it be nice if that was all automated and you could leave, you could use your time for maybe threat hunting or more strategic sort of things, rather than hand bombing in IP addresses, MAC addresses, and other mundane type of things. And this is all built around trying to increase efficiency, right? Trying to contain a breach faster, right? So when things are integrated and automated, and you're doing things less manually, we're going to be able to get to a process or to a state of security where you can contain things much, much faster than if you're trying to do this manually. Now, the other point I want to make here too is DevOps and DevSecOps, if I can use those interchangeably, isn't just about scripting. It's not about infrastructure as code. And in fact, I would even argue that your script kiddies, your programmers, the guys that love Python, that job in and of itself is likely to go away to some degree as well. A lot of DevSecOps capability is actually being put into what I'm going to call normal language. You don't have to be a script kiddie. You don't have to be a Python expert to take advantage of this mindset. Now it can help, but we'll talk about that as we kind of go through other parts of the presentation. All right, another little stat to throw up here. Top reasons for DevSecOps. So what is the primary reason your org employs or plans to employ DevSecOps? And really it's all about security, right? So if you look at some of these stats, and I won't go through all of them in the interest of time, but number one, the yellow guy there in the pie chart, again, this is done by ESG research. It's all about the ability to allow us to improve our security posture by making sure cybersecurity controls and processes are tightly integrated with our business. The other big one, number two from the top there, making us think about security proactively, right? So, and that's really speaking to the automation piece of DevOps. Containing a breach without me having to wake up in the middle of the night and log into the firewall or log into the endpoint console and try to figure out if this is really an attack and who's being breached and who needs to be quarantined. Wouldn't it be nice if that was all just automated? So the alert you actually get is that, hey, guess what? Joe Blow downloaded malware, but we put him on the quarantine VLAN, or we've taken that server offline, et cetera, et cetera. That's really where DevOps or DevSecOps is all about. That's where it's providing value. So let's take a bit of a left turn. Let's talk a bit about security strategy and how DevOps falls into that. Now, I'm going to kind of talk about Fortinet security fabric, and I'm trying not to be overly salesy today. So I'm not necessarily pitching Fortinet here, but I'm going to use this as an example. And there's others out there today that'll have a similar concept and strategy. In fact, when I used to work at McAfee years ago, I would venture to say, and hopefully my boss is not on the line today, but I would say McAfee was a very early adopter of this back in the day, maybe ahead of their time, in fact, where they saw the benefit and the need for the industry to move to an integrated, automated approach. And so again, just giving a plug to others here that have the same sort of mindset. But really what we're talking about here is a strategy for a holistic, integrated concept of IT security, not having things in silos. And there's a reason for this. And just kind of bear with me here as I sort of go through this at a high level. So in terms of a security fabric, the first thing that we're interested in is trying to create this broad visibility of all the different ways in and out of your network data can flow. So firewalls, mail gateways, web gateways, visibility into your cloud, visibility into your SaaS apps, endpoint, IoT, all of these different, what might look like point or silo products. We need these covering all of the different doors and windows and ways in and out of your network. Because if I can't see all of the different ways that data and users interact in your network, I can't fully understand the risk that's involved in your business. And so that's why your strategy needs to be broad. You need to be covering off all the different ways in and out of your network that data can flow. And we do that for a couple of reasons. And the first one is going to be to integrate these things together, right? So integrating endpoint with sandboxing and sandboxing with the firewall, and so on and so forth. At the end of the day, we want to integrate these things together so that they can share data, and more importantly, that they can share the ability to enable action when something goes wrong somewhere else. That's how we get to a point of protection faster. And the ultimate point of protection is automated. So the holy grail of this whole strategy is to automate all of these things together so that you're not having to do these as a manual process. So again, giving that example earlier where in the middle of the night when you look at your phone because it's buzzing like crazy and blowing up, the alert that you get is hopefully the one that says, hey, Joe Blow downloaded some malware, but it's okay. He's being quarantined and you can go deal with it tomorrow morning, or he's automatically being scrubbed. We've ripped out all of the traces of malware, the registry, whatever was done, or we've gone back to a known good. That's a much better email in the middle of the night than saying, hey, your world's on fire, go put it out. Okay, let's talk about Carda. So I don't know if you're all familiar with Carda, but Gartner has a model, a security model, called the Carda model. And really it's all about, not to be glib, but it's all about keeping out bad stuff and letting in the good stuff, right? So what we mean by that, or what Gartner means by that, are a couple of key points here. So Carda is all about continuously monitoring and continuously assessing risk and trust. So as devices come in and off the network, what we allow those users and those devices to do is all based on whether they are clean and safe enough for us to let them touch the resources that they want to touch. And of course, authentication goes hand in hand with that. Are they also authorized, right? Which speaks to trust. But this process isn't just a one-time thing. We have to continuously monitor their behavior. We can't, just because they came in this morning all honky-dory, doesn't mean by 4 o'clock this afternoon that their trust level and risk to the business is the same. So we need a process of continuously monitoring and looking at these users and devices. The other point Carda tries to make is enabling adaptive responses. And this starts to speak to integration and automation a little bit. Then they talk about baselining existing systems. And this is really talking about user behavioral analysis. Talking about users and devices doing things today that maybe they haven't done before, things that they maybe don't do normally. And then anticipating threats and attacks. That's the other piece of Gartner's Carda model. So to kind of put this in perspective, Carda lays this out in seven different imperatives if you've ever read their document. That's all about replacing one-time gates with context-aware programmable platforms. So programmable being the key word here. We talked about continuously discovering and monitoring, performing risk and trust assessment, instrument infrastructure for comprehensive full stack visibility, utilize analytics, automation. So number 5, that's another big bullet point. That's really, again, speaking to the DevOps mindset in this model. It's all about automation, orchestration to speed up detection and response. So number 5 is a big one. Again, speaking very much to how the Carda model very much has an eye towards this whole DevSecOps mentality. Number 6, architecting security as an integrated, adaptable, programmable, let's use the word orchestration, system. And so, so Carda, the point I'm trying to make here is that Gartner also feels very strongly about a DevSecOps mindset. And you can see it in the Carda model here in the imperative, these 7 imperatives, where this whole idea of orchestration and automation is really throughout the whole model. So Fortinets has something called the dynamic adaptive security architecture. This is really very similar to the Carda model. I'm going to kind of flip through this in the interest of time. But these last sort of 2 sections, or these last 2 steps of this 5-step model or architecture is all about rapid response. And it's all about, after we've sort of built out a model of, web application firewalls and next-gen firewalls and mail gateways and, protecting SaaS apps with CASBs and web gateways and whatever else, we might have sold into that network and put into that architecture. At the end of the day, as we're getting threat intelligence, as we're getting alerts, as we're getting information into our security operations, we're then at a point where we can use tools to start remediating, quarantining, when we see these threats, or cleaning up, right? So it's not always just about quarantining something and shoving it in the corner or in the closet and forgetting about them, but automating even the cleaning up of that endpoint, or getting that endpoint back to a trust, or a state of trust. That's really step number 4 in this dynamic adaptive security architecture, using tools like SOAR, which we'll talk about, using the APIs, using some of the built-in GUI-based automation tools that'll be available. All right, let's get back to maybe more of a DevSecOps conversation. So some key use cases, and number 1, the auto deploying of services and resources. This is probably the real low-hanging fruit from a DevOps perspective. And this is the ability to auto deploy security at the speed of business. We kind of talked about this as a problem earlier on. Just doing a bit of a time check. Where maybe the business in their digital transformation story needs to deploy things up in the cloud as they spin things up at lightning speed. Security needs to come along for the ride, but not as an afterthought. It needs to be done at the time of deployment. So as web servers are being configured, as cloud infrastructure is being deployed, gateway, next-gen firewalls and gateways, web application firewalls, whatever it might be, that's offering maybe some microservices, sort of segmentation to maybe a Kubernetes deployment. All of this needs to be done simultaneously. And so this is being done with tools such as maybe Terraform or Ansible, some of the built-in cloud scripting tools with Amazon and Azure. But that's probably the main, the low-hanging fruit behind this whole concept. I'm not really going to get into that anymore, though. I really want to shift more to the next two, or three for that matter. So the other low-hanging fruit, or other main use case for DevSecOps, is the ability to auto-quarantine infected endpoints and users and devices, right? So what we can do with a DevSecOps mentality, automation and integration, is when intrusions are discovered or a breach or a successful breach is being detected, malware is being downloaded and executed, and we can go on and on with the example. The ability for the infrastructure of the network to auto-quarantine the things that have been infected or the things that are at risk away from what's healthy, and then being able to take that intelligence that it's learned from this breach, whether it's source IPs, MAC addresses, URLs, hash values of malware, then being able to share that data with other systems where we can then go do some further threat hunting to see who else has been infected. And then adding these IOCs, these indicators of compromise, we can add these to various gateways to blacklist any further communication or attack from these sources or destinations. So that's really the other two sort of main use cases where we're seeing DevSecOps being used today. And then the fourth one is unlimited. Because a lot of this is API driven, it's programmable. At the end of the day, these use cases are only limited by your imagination. There's literally nothing you can't do if it's available as a command. So if your API is basically a mirror copy of everything that your product can do from a feature perspective, there's really nothing stopping you from developing your own use case other than your own imagination. So we really talked about this one already. I'm going to skip this one. So let's talk a bit more about automating security. So some of those use cases that I just mentioned, and we'll kind of go through some of the building blocks and some of the details. So we really have a concept of triggers versus actions, and then these actions can be automated, as I've kind of mentioned throughout this whole conversation. So triggers are going to be things such as system events. So a system event could be literally almost anything that's logged. You can create a trigger from that event. But some of the big, the low-hanging fruit ones would be malware detected, or an IPS event has been detected, or someone has gone to a bad website. And we'll go through some other examples. User and device status. So this could be another trigger. New device has been detected that we've never seen before, or a new user logs in from a place they've never logged in from before, or a device logs in who's just failed his vulnerability scan, or has exhibiting too many critical severity level vulnerabilities. And there's millions of other examples. There's just some low-hanging fruit from a trigger perspective. Then on the flip side of that, we have the ability to define actions. So if we don't like the fact that some device has just showed up on our network that we've never seen before, or that it has too many vulnerabilities that we're just not comfortable with, or that he's got malware or downloaded malware, whatever it might be, we then have the ability to do things such as notify, send a report, quarantine the user. And we'll talk about what that means, because that can go in a million different directions. Or we can adjust configuration. We'll talk about that. So triggers. So I kind of talked about these already. So let's talk about a few more. So we talked about compromised host, however you define that. Someone with vulnerabilities, IPS events, downloaded malware. Another trigger could be something that we've learned from the cloud itself. So the cloud's sending us information, whether that's something from Azure, Google, depending who it is. We can also enact, or we can also absorb data from those systems as we're building out a whole response sort of playbook. And that could come in as an incoming webhook. So we'll talk about what webhooks are in a minute. And then actions would be things such as quarantining at layer 2, right? So taking the MAC address or taking that user, throwing him into a special kind of VLAN where he might only be getting access to remediation capabilities, right? Like being able to update his malware engines or having the system cleaned or what have you. Same thing with quarantining the client. So rather than putting this user on a VLAN, we actually could take that user and quarantine them completely off the network without having to put them on a VLAN. We can actually enforce that right at the client side. So some of your various clients, EDR endpoints out there can do that as well. So we don't necessarily have to put somebody on a special VLAN for this purpose. We can also do things such as banning IP addresses on the firewalls. And we can take those IPs and share them across the infrastructure. So if you've on a gateway in Calgary, you're being attacked by a certain source. That source intelligence, you can then propagate that to your cloud infrastructure. You can send that IP to all the other gateways throughout the rest of your network, all of your branches, because maybe they're going to attack a branch next. Maybe he'll attack the cloud. But if you share that source information with all of your infrastructure, then hopefully you can make things a lot easier for yourself. Things like that. An action could also be another webhook. So webhook is really just another instance of programming. Right? So an incoming webhook might be somebody talking to one of our systems. So talking to a firewall, for example. But it could also be us sending a command to somebody else as a response. So maybe, again, it might be something like assigning a tag to Azure, right? So we see something in the cloud that's vulnerable, or something communicating something in the cloud that's vulnerable, or exhibiting some sort of cybersecurity event. We can tag that with cloud tags. In fact, there's one built into the box today with VMware for NSX. And then VMware would then have the ability to then say, hey, anything with this tag, we will do this. And so you can kind of see how these things will play off of each other. Do a quick time check. Okay. And this is perhaps an example of how some of this would work. So let me just sort of show you a bit of an example here of how an automated integrated solution from a malware point of view could work. And we'll talk about this from both a Fortinet perspective, where everything's kind of the same vendor, where of course automation becomes easier, but we can also talk about this and how it would work with third party. So we've got some gateways of various kinds. On the left, we've got next-gen firewalls, we've got some mail firewalls, we've got some web application firewalls, load balancers, and then a web gateway. On the right side, we then got our EDR clients, next-gen AV agents, whatever you want to call them, maybe protecting servers and endpoints. And so the whole idea here, as we sort of add this technology with malware analysis tools such as sandboxing, is we can then, maybe there's an endpoint. He downloads some malware today, never been seen before. It's a 0-day. As he downloads this file off the web or from his email, that file is then thrown over to a sandbox, a malware analysis engineering tool, file analysis tool. This tool takes a look at the file and determines that, yeah, this is malware. There's a URL in here we don't like. There's some IP addresses for command and control channel. There's some registry settings that are malicious that are going to be used for encrypting the hard drive, so on and so forth. It takes a snapshot of the file, creates a hash value, and basically all these IOCs and threat intelligence that the sandbox now has at its disposal from this threat intelligence scenario that it's carried out within a couple of minutes of getting the file. He then can share this with all of that infrastructure, all of the firewalls that might exist throughout the network, whether there's some in the cloud, up in Amazon, in Azure, at a branch office, in your own data center. which you can share it with the mail appliance, so on and so forth. And then, of course, with the endpoints themselves. That endpoint or a SIM, this can also be shared out with somebody's SIM. And then maybe that SIM tool, you can then use it, or the EDR tool, you can then use it to say, hey, maybe we've seen this IP address before. Maybe we've communicated to this URL before. Maybe this hash might live already within our asset inventory. And then we can use threat hunting capabilities based on the threat intelligence that we've learned from some of these other tools to then go hunt from what we've just learned from this one endpoint having downloaded a piece of malware. And at the same time, this endpoint, who perhaps detonated the file, would then be quarantined, put onto a VLAN perhaps for remediation, and cleaned up before he's hopefully infecting anybody else. So very automated, very complete sort of A to Z strategy that's made possible through automation and integration. And in the case, this is all done easier when it's vendor, when it's all the same vendor. Not always a realistic sort of undertaking. Most customers are going to have multiple security vendors in their network. And that's where the APIs become important. So there's no reason you can't do this with practically any vendor, as long as there's APIs that vendor is publishing and creating. And so a lot of this can be done from vendor A to vendor B, even though there's no official sort of integration between the two, just by using these webhooks that I showed you earlier, by essentially taking advantage of API calls on how to move IOCs and enact actions from one device to another. This is what a webhook might look like from a Fortinet perspective, from a FortiGate perspective to be exact. So this is just showing some JSON commands being put into a RESTful API call, essentially. So one of them here is basically just showing us, showing you how to log in with this webhook into a FortiManager. So this would be at the beginning of a script that you might be doing all sorts of different things with after the fact. And in fact, the other picture that we're showing here on the bottom left, this looks like it's showing a webhook that is taking a source IP and a MAC address and probably putting this onto a quarantine list with a webhook. So you can see the URL that they are using, that they're calling up. There's a concept of an API admin key for security. So this is just a quick example of what a webhook would look like. We talked about this already, so probably in the interest of time, I'll skip this one. But really, this is all about, let's not forget about the cloud, especially as we talk about DevSecOps, because so much about DevOps is about the cloud, and there's so much about the cloud that can leverage DevOps. But really, what we're talking about here is more from a security perspective, in terms of the ability for us to interact with the cloud and quarantine things in the cloud. With these various integration API calls that can be made possible, right? So let's not forget about that as well. It's not just about quarantining or taking action on our own infrastructure on-prem. We can also do this with whatever we have in our cloud infrastructure. Some other triggers that we can also talk about, these ones in the middle. So security rating summary. So what security rating is, this is a bit unique. Security rating is all about the ability to take action upon a security audit. So security rating is a service that'll run on the FortiGate, for example, and it'll look to see what the configuration looks like. Maybe you're using weak passwords. Maybe you're using DES instead of triple DES or AES. Or maybe you don't have profiles with antivirus and IPS. Maybe your admin account has got a weak password, things like that. As the result of this security rating becomes known to the network or to the infrastructure, we can use that as a trigger. So maybe your security rating sucks today. You've gotten to a particular score that's pretty bad. showing that your FortiGate is misconfigured, we can have an action as a result of that. Maybe somebody's changed the configuration and you want to be notified of that configuration change, or you want to revert back to a different configuration. We can do that. And none of these actually would require any Python, any scripting. These are all pre-built, out of the box automation integration capabilities. So none of these are going to require any sort of specialized knowledge. And that's kind of key to my message today, is that don't think of DevSecOps as necessarily somebody who's just writing scripts and has to know the API backwards and forwards. A lot of this is being built into the products so that you don't have to be that guy necessarily. Now, it's going to help, though, I won't lie, and we'll talk about that in a minute. But again, HA failover could be an event. Maybe AV or the IPS database is being updated. A lot of customers like to get notified when an AV or IPS database is being updated. They want to be able to see an alert so that they know that if things hit the fan a couple of minutes later from a bad update, they'll be able to go, oh, you know what? I just had an AV IPS update 5 seconds ago. Let's go look at that. High CPU or memory overload or memory capacity issues. You can also use these as triggers for doing things. And of course, they can all be scheduled. Right. So again, this is just getting back to the different ways that you can think about DevSecOps and automation, and getting back to that one bullet point I had on use cases, where really this is just limited by your imagination. So, where there's a lot there that we've pre-built for you, really you're only limited by your imagination. Okay, now let's close off with SOAR. I'll try and do this a little bit quick. I'm going to run out of time in a few minutes. So SOAR stands for Security Orchestration, Automation, and Response. If there's one tool in the security marketplace today that's about DevSecOps, it's SOAR, right? So this family of tools is really all about automation and orchestration for security operations, right? So these are tools, systems, applications within an organization that really enable any team to automate incident response workflows. They're really trying to take the DevSecOps, or the traditional approach or definition of DevSecOps, out of this picture. That's why they cross it out here in their good little slide here. They're really trying to say, hey, you don't need to be a Python expert to make this work. If you want to automate, if you want to triage, you want to threat hunt, don't think this has to be done with a whole bunch of open source tools like Lego without a manual and a whole bunch of scripting and programming. SOAR tools are trying to take away all of that so that they can try to make this a much easier, quicker solution to put into place from day one. Hope that makes sense. So, quick little example of how a SOAR would interact with the world. So think of SOAR as different from SIM. Don't get them confused. Everything in your network would probably still flow to something like your SIM, right? So your SIM is still going to be your central place of all logging, of all reporting. And then what your SIM does is it's going to filter up the important alerts, maybe the higher severity alerts, depending on your use case. But the SIM is then going to forward this data up to your SOAR tool. And your SOAR tool is basically going to be where you're going to research threats, you're going to execute remediation of threats. Maybe you're getting a phishing attempt that the SIM is throwing you alerts on. You can use the SOAR tool then to figure out, okay, exactly who's gone to that website, how bad is this website, and then because you're going to integrate your SOAR tool with your firewalls and your web gateways and your mail gateways and anything and everything else that you can think of with connectors, the SOAR tool is then going to be the place where you remediate. You will enable automated actions where the SOAR tool will then take that domain, that URL, and he'll put it on the blacklist for for this phishing website. He can put it on the next-gen firewall. He can throw it into the SIM as well. He can throw it into whatever tools, web gateways, but whatever tools that you need to automate with. That's what the SOAR is all about. So it's about opening tickets, case management, standardizing investigation and response to security incidents. That's really what a SOAR tool is all about. A quick few snapshots of the GUI in a SOAR, just to sort of show you what this looks like. And there's going to be some pre-canned playbooks, of course, that are done out of the box. But you, again, limited only by your imagination. This is showing you the ability to drag and drop different variables in building a playbook out. No coding required at this point, just the ability to drag and drop. If you've got a mouse, you can build a playbook in the SOAR. And again, this is just showing you sort of the start of the whole process, some of the different steps and different variables that are available to you. So again, you might build some for phishing responses, right? When you get a phishing alert, how do you want to build out your response? Do you want to build out a response that says, hey, let's go to the firewall and block the URL? Let's take the source IP and put him in on a quarantine list. Build a playbook that would show exactly that. Drag and drop. Once you've added your connectors and your devices, it's just a drag and drop scenario on how to play that out. Maybe you want to add a few things to it. So maybe as part of your phishing exercise, you want to go to VirusTotal, or you want to do an IP reputation lookup, or you want to go to the FortiGuard web filtering database to go add him, or request that FortiGuard or any other sort of threat intelligence web filtering solution who hasn't looked at that as a phishing URL, maybe re-examine that on their own so they can add it to their own threat intelligence. So a whole bunch of different sort of things you can add to these playbooks on your own. And I'm probably going to leave it at that. I'm going to run out of time. I think we're about 3 minutes over. So I think you get the idea here, guys. So I just want to kind of, again, basically just close off with this whole concept of integration and automation. Let's call it DevSecOps. But really, it's all cybersecurity today. If we're going to do a better job, if we're going to do a better job of deploying tools, if we're going to do a better job of protecting systems, it has to be done with a DevSecOps mindset. It's got to be done through integration and automation, because there's really just no other choice. There's no other way to scale today without thinking about IT security operations in that context. Thanks for attending today, guys. Take care.